Okay, I think this will probably be our last chapter of the whole year. How about that? It's kind of exciting, isn't it? And what's today? Today's April 23rd. Is next week going to be May? Probably. Or next week I think is going to be May, isn't it? And what does that mean? So that means what? Yeah, next Wednesday is the first day of May, May 1st. So that would be our last month. All right. What did I just do with that pen? I just had it. Did I put it back in my pocket? I didn't. Did somebody steal it? Where did I put it? What's going on? I just had it in my hand. Did I drop it? The pen that I used to write on this? Who just came up here? Did you steal my pen? Did I drop it on the floor? That's weird. Didn't I just have it? It's not there. It's not there. I may have to pause this until I find that pen. Is it underneath? Oh, here it is. Man, if it was a snake, it would have bit me. You ever hear that phrase? You never heard that? It's like an old person's phrase. Do you get the phrase?
Yeah, because if it was a snake, it would have bit you.
Yes. Pretty self-explanatory, isn't it?
Yeah.
All right, here we go. Circles. That's what this whole chapter is about. We did a little bit of circles last chapter, didn't we? So where are you guys, Mount Pleasant?
Yep. How'd you know?
Because I looked. All right, well, good luck to you guys. Actually, last year I went to the Mount Pleasant game.
Yeah, you took pictures.
I did. All right, make sure you watch the video, do the homework. You got it? Okay. All right, so let's just go through some basic words. We did a little bit of circles this last chapter, didn't we? What did we do? What did we do? Like area? Did we do the sector and segment? Was that you guys? Yeah. So we did not a bunch, but we did a couple lessons, right, with circles. So we did area of a circle, we did perimeter, the circumference of a circle, we did the area of a sector, the segment, all that kind of stuff, right? Well, this is going to be a little bit different. We're not doing area. I don't think we have any area in this chapter. I don't believe. I think we covered all that. But we're going to learn a lot more stuff about some circles. So we probably talked about this when we talked about circles for the first time. We talked about area and stuff. But what is it? Let's do this word right here. That little point, I'll say it's in the middle, but we don't call it the middle of the circle. What do we call that point? Center of the circle. Very good. Again, I can't remember. I've taught this to so many classes, I just can't remember who I taught it to. So if I repeat some stuff, that's okay. It'll be good to learn it a second time, I guess. What about that line segment? It goes through the center, all right? Specifically goes through the center, and I can give that a specific word. Anybody know what that is? Diameter. Very good. This stuff you probably knew before you even took a geometry class. What about this part? From a point on the circle to the center. If I draw any line segment from a point on the circle to the center, Gianna, what'd you say? The radius. That's the radius of the circle. Give me a relationship between the radius and the diameter. Any way that you want to give it to me, I don't care. The radius is double. Think of it. Look at it. Does the radius look twice as big as the diameter? No. I know what you were thinking, though. All right, the radius is how much of the diameter? Half of it. It's half of the diameter. But you could say it this way. You could say the diameter is what of the radius? Is double or twice. Okay? Everybody got that? So one diameter, I don't usually write this, but I was just thinking about it. One diameter is equal to how many radii? 2. Have we talked about that word radii? Yeah, what does that mean? It's plural, right? It's plural of radius, okay? And that's how you say it, radii. All right. Let's introduce another word. Let's put a different color since I got all that white going on here. What if I just went from a point on the circle to another point on the circle, but it doesn't necessarily go through the center? Do you agree that's true about that red segment right there? It's a point on the circle. When I say on the circle, a lot of people get confused. A lot of people think of a circle as a disc, right? As a plate, like a pizza plate, like a plate you eat your dinner on, that kind of thing. A lot of things, and they think on the circle is this. Is that point right there on the circle? No. What would we say is true about that point? It's where? It's in the circle. What about this point out here? It's outside the circle, okay? What about a point right there that's on the circle? Everybody see that? So if I connect 2 points on the circle, so there's a point on the circle, there's a point on the circle. If I connect with a straight line 2 points on the circle, we call this a chord. So that's probably something you haven't heard before, would be my guess. Maybe you have, maybe you haven't. You probably heard of diameter, you probably heard of radius, and you definitely heard of those because we did area with radius, didn't we? We did circumference with radius and diameter. All right, so you've definitely heard of those. All right, the chord is probably the one thing that you probably have not heard of. All right. All right, let's talk about this. Let's call this A and let's call this B. Let's move it up. So if I ask you to name this chord, what is it? What kind of thing is it? Is it a line? Is it a line segment? Is it anything else? I don't know. I can't think of anything else it could be. What is this thing right here from A to B? So this line segment AB, well, I just gave it to you. It's a line segment. Okay, it's a segment. Yes, very good. It's a segment. But what I want you to look at here is this. Watch this. I'm going to go around the circle from A to B. So I'm going to go from here along the circle to B. That's curved, isn't it? So is that thick one right there that I just drew, is that line segment AB? No, this would be a chord. And we don't have like a symbol or anything. We would just write the word chord in front of it. Okay, but we don't even deal with just chords by itself, but we just write chord AB. In fact, I don't even think they put that little line segment on top of it. So that straight line right there would be chord AB. What about the curved one, the one that's going around the circle? Okay, we call that, just put it right there, thank you. We call that thing an arc. And we're going to be talking about arcs a lot. This is the first time you've heard it. It's not going to be the last by any stretch. Okay, we're going to talk a lot about the arc. So we could talk about arc AB. What is arc AB though? Is it what? Is it the straight line? No, it's the what? It's the curved one, okay, from A to B. Everybody see it? It's the one that's a little thicker on my picture right here. So that would be an arc AB. Now, we actually do have a symbol for arc. You want to see it? So we would write AB, and then you'd put this little curvy thing, like a little hat on top of it. Okay? What does that mean? That means arc AB. So we don't have to write the word in front of it. If I just talked about a chord, you would have to put the word chord in front of it. All right? There's no symbol for it. Right? But if it's an arc going around the circle right here, it's not a straight line, it's a curved line, isn't it? Okay, and it follows the circle like this. Yes? Do they do this now or do they do this later? It looks like they might do this later, but I don't see it in my notes, so I think I'll talk about it now. Yep. I thought I would have put this in my notes, but let's talk about this right now. And it may come up later. We'll just deal with it right now. Okay. While I'm thinking of it, might as well. It's probably in my notes in some other lesson, but I'm going to talk about it right here. This, let me ask you about this. What about from here to here? Is that a chord? Let's make it a different color. Is that blue in a chord? What do we say? What do we say? Chord? Yeah. What do we say about a chord? What's that? I didn't say that. Okay, I didn't say it doesn't go through the center. I said it doesn't necessarily. Listen to me. It doesn't necessarily go through the center, which means what? It could go through the center. All right. Say it to me. What did I say about a chord?
2 points on the circle.
That's right. It's just a straight line. It's a line segment that connects 2 points on the circle. This blue one. Does it connect 2 points on a circle?
Yeah.
Absolutely. So is it a chord?
Yes.
Yes, it is. What about a radius? Is a radius a chord? No, because it connects the center to a point on the circle, but it doesn't connect 2 points on the circle. Everybody got that? So radius is not a chord. A diameter, yes, it's a chord. It's a specific type of chord. It's a chord that does what? Well, any chord connects 2 points. But it's specifically a chord that does what? Come on, look at it. Look at that blue one. What's it do specifically that the red one doesn't do? It goes through the center. That's right. All right, so a diameter is a chord that goes through the center of the circle. Make sense? All right. So you could have chords all over the place, couldn't you? All right. There's a million of them. I mean, really, literally, there's an infinite number of chords that you could draw if you wanted to. We're not going to draw an infinite number of chords. That might take a while. So we're not going to do that. So let's talk about this. This diameter right here. Look at the... What if I wanted to talk about this arc that diameter makes? Oh, I didn't mean to go squiggly right there. I just, my little tablet shifted a little bit. But get the idea. You get the idea, right? I'm talking about that whole thing right there. Everybody got that? So what can I call that? Remember, I call this arc AB. Yes? What, this big, thick blue one. What could I call that? Arc CD. But how do I know if I'm talking about this one? I could be, well, might as well try it again. Let's see if I can do it. Then what would that, I get to a certain point, my hand's too shaky. Once I take my hand off that tablet, let's see if I can do this. There we go. That's better. Look at that yellow one. What would I call that yellow one? So I got a little problem here. If I said arc CD, how would you know if I'm talking about the blue one or the yellow one? I mean, they're the same. Well, I'm not even going to talk about the degrees or anything. We'll talk about that later. But how do I know which one I'm talking about? I got to have something else, right? So let's go back to the yellow one because I've got some points here. What if I wanted to describe this yellow arc right here? I can't just say CD because I could be talking about the blue one, which is CD. Yes? Everybody understand what the question mark is? Yeah. So how do I know I'm only specifically talking about the yellow one? Well, I could put another letter in there. So I could start at C, and you could also start at D. It doesn't matter. Like C, D, D, C, right? We've done that before with like lines, haven't we, in line segments? Yeah. So how else could I do it? I could say it starts at C. Give me another point that it goes through before it actually hits D. A, all right? And then where does it end? D. So I could call it arc CAD. That way, if I said arc CAD, you know exactly I'm talking about the yellow one. There's no way that could be the blue one. Do you see it? Yes or no? All right, because if I said arc CAD, it starts at C, it goes through A, and it ends up at D. That's what that means. Does the blue one do that? No. It starts at C and it ends at D, but it doesn't. The blue one doesn't go through A, does it? Or I could call it something else. We'll keep the C and the D in the same order. So let's say it starts at C. Is there another point that it goes through? Yeah, B. Now, I don't have to put them both, so I don't have to call this CABD. We're only going to use 3 letters, all right? So it just has to be some point that arc goes through. So it starts at C, it goes through A, ends at D. So I could call it arc CAD. Or it starts at C, it goes through what? B, remember, because there was a big point right there? Remember that? And then it hits D. So I could call this what? Arc C what? BD. Either one of those. We call this, well, I'm not going to talk about that in a sec. That's good enough for right now, okay? Yeah, let's talk about it now, okay? If this is the diameter, how much of the circle is that yellow one, and how much of the circle is the blue one? It's half of the circle. So if it's exactly half the circle, starting at C and going through D, which is the diameter right here, CD is the diameter, we call that a semicircle. You've heard of that before, haven't you? Yeah. but you probably didn't know exactly what that meant. A semicircle is exactly half of a circle. Yes? We're not really getting into it right now. We will eventually, but while I'm thinking about it, how many degrees is all the way around a circle? 360 degrees, okay? So, how many degrees is a semicircle? It's 180 degrees, that's right. So a semicircle is exactly 180 degrees. Now this blue one right here, I really can't name it unless I did what? I can't just say arc CD. What would I need in order to talk about arc CD? This blue one. What's that? Another point. Yeah, I need another point. So let's put another point. It doesn't matter where it is. Let's put it right here. And we'll call it point E. All right? So now this blue one, and I'll keep it blue right here. What could I call that blue arc? I could call it what? Start at C. C what? C, E what? D. That's right. Now it's the same degrees, isn't it? Same measure. So it's still what? How many degrees is that arc? It's still 180 degrees. And by the way, that's how we measure arcs. We measure arcs in what? Degrees. That's right. Okay, everybody got that? So this yellow one, which would be arc CAD, that's 180 degrees, and arc CED is also 180 degrees. What's another way I could name arc CED? Only one other way. DEC, right. I could call it arc DEC. So I could put arc DEC. It's the same exact arc. It's just another way to name it. Everybody got it? Yeah, so this beginning part is just understanding how to name things and all that. We might as well do this while I'm here. I don't think officially we're doing this, but when we actually get to this in another lesson, we can kind of skip over it a little bit. What if I had, what do I want? I want B. That's what. Okay, so watch. What if I started, I don't know, that E, I made it look too much there. What if I put that E right here? Is that all right? Okay, so watch. I'm doing that for a reason. There we go. And let's change this. Change it to green, so change it to green. What if I did this? What if I went from A to E? Oops, missed it. Anyway. It's not as easy as it looks. What could I call that green arc? I could call it ACE. All right, technically it wouldn't be wrong, but I don't really need the C here. You only need the middle point when it's 180 degrees or what do you think? Or more, okay? If it's 180 degrees or more, that's when I need the 3 points. Okay, but if I'm just going from A to E, does that look like I went up more than 180 degrees? No, because from like here to here would be 180, wouldn't it? So I call this green one right here, I call it a minor arc. Why do you think it's minor? Because that arc is less than what? 180 degrees, exactly right. So it's less than 180 degrees. All right, let's throw another color in here. Man, I'm really using this triangle, aren't I? What if I went from E? Oops, why didn't it turn colors? I thought I changed the color. There we go. All right, what if I went from E? Oh, I'm so nervous. What if I went to there? That pink one right there, okay? Is now, again, from here to here would be 180, wouldn't it? All right? So what is this pink one? It's a major arc because it's what? More than 180 degrees. So this pink one right here we'll call a major arc. And it's, we'll say greater than. Sounds a little more mathy, doesn't it? Greater than what? 180 degrees. So anytime you have a major arc or a semicircle, how many letters are you going to use to represent that arc? 3. Okay, if it's a minor arc, how many letters are you going to use? Just 2. Everybody see that? And you'd use the endpoints. So this green one, what would I call that green one? Arc what? AE. All right, so let's do that. So I'd call this, the green one, arc AE. And what if I wanted to name the pink one? Yeah, you could go ADE or you could go ABE, right? It doesn't matter. All right, it's the same thing. I'll go the D. All right, so arc A what? DE. And how do you know? Just by looking at this, what can I tell you about the arc? It's either what? It's either a what? A major arc or a, no, it can't be a minor. It's 180, which is a what? Which is a what? Which is a semicircle. Okay? Everybody got it? All right. So this is all just kind of understanding the words. Okay? It's just vocab, basically, is what we're doing. And a little bit of notation, all right? Just to show you what that arc thing means. Wow, that's a lot of colors. All right, let's actually do some stuff that I wanted to do today. So we may not finish. It's 10 of in here today, right? Do you know what that means, 10 of? 10 minutes until the hour, which means 1:50. All right, this is almost one of those throwaway theorems. Hate to say that. Geometry people that do this all the time might get mad at me for saying that, but it's kind of a throwaway theorem. But look at that line right there. Is that line a chord? Is that whole thing with the arrows and everything? Is that a chord? No? What's a chord? It's got to start and stop where? On the circle. This doesn't start and stop on the circle, does it? Okay, the line itself, okay, is not the chord. What is the chord here? The line what? The line segment is the chord. Okay, starting at A, going to B. This part right here is the chord. Everybody got it? But the whole entire line is just a line. Okay, nothing special about it. It's just a line that goes through the circle. That's all that is. We're going to learn another word later on in a different lesson, and we're going to give that line a name, but not today. All right? I don't think today we are going to. Nope. So all this theorem says is this. It says, if a line intersects the interior of a circle, does this line go through the interior, the inside of the circle? Yeah. Then it contains a chord of the circle. That's all it says. It's kind of weird. If you have a line that goes through a circle, then it also has a chord. All right? And it contains a chord is what it says. So the chord would be what? How would I name the chord? What if I asked you to name the chord of this circle? What would you name it? AB. All right? And since it's a line segment, what would we do? Put a little line segment over top. Don't put an arrow. But if it says name the chord, then we would just say this part right here is the chord, and we just call it line segment AB. That's the chord. Okay, that was pretty easy. Let's do another theorem that we are going to use. Let's just copy this thing. All right, another circle. Now, this is kind of interesting. What if, let's get rid of that. Oh, I need the center. So the center is right there. Okay. Let's do this. It says, if a radius is perpendicular to a chord in the circle. So here's a chord. Okay. And it says, if a radius is perpendicular to the chord. So do I want to make my radius right there? Do I want to make it right here? Now, what do I want to do? Make it perpendicular right there. And I'm going to take it all the way to the end. So it's an actual radius. Okay. Everybody with me? Here's what the theorem says. And you could probably guess. I bet you anything that you could guess what this is. Let's label this. O, A, D, C, and B. So I said, if the radius is perpendicular to the chord. So I made it so it was perpendicular. Everybody see that? So I specifically drew these things so that radius and that chord make a right angle. What do you think that radius does to the chord? It doesn't just intersect. It intersects at a lot of different places. Say it. It bisects it. Very good. So This is a D. So line segment AD is going to equal what? Line segment DB. That's right. So those two would be equal. All right. So what were we given? We were given that OC, line segment OC was what? Perpendicular to what? Line segment AB. If those two are perpendicular, then what can we conclude from that? We can conclude that AD, line segment AD, is equal to line segment BD. Thank you. Everybody see that? All right. What if you did this? I'm not going to redraw this. We could actually do the converse of that. Flip the if and the then. All right. So this says if these two, the radius and the chord, are perpendicular, then the two segments of that chord are going to equal each other. Does that make sense? Yeah. What's the converse of that? If what? If the chord is bisected, right? Which means that this and this are equal, yes? Then what do you think must be true about the angle that OC makes with AB? It must be what? It must be 90 degrees. It's got to be right. It's got to be perpendicular. Do you see that? So it says, if the chord is bisected, then the radius is perpendicular to the chord. That's what the second theorem says. So what did the first one say? The first one said, if the radius and the chord are perpendicular, then the chord is bisected, right? That's what the first one said. Then the second one said, okay, what if we don't know that's perpendicular right now, but we do know that the chord is being bisected? What must be true about the radius and the chord? They got to be what? They got to be 90 degrees perpendicular. Okay? See how it works? All we did was switch the if and the then. Okay? So if they were perpendicular, then the chord was bisected. That's the first theorem. The second theorem, the converse of it, says if the chord was bisected, what must be true about the radius and the chord? They must be what? Perpendicular. Make sense? Yep. So what do you think is true about D? I just gave it to you. Man, just gave away the secret. Yeah, what would point D be? That would be the midpoint of this chord, wouldn't it? Okay, because if it was bisected. Yeah, that's good. All right, you want to do another one? So that's two theorems down. If it lines the next theorem, I'm not even going to do this. The next theorem, they just say I'm just skipping that. I'm going to go right to an example. Okay? I've already drawn it, so I'm just going to get rid of a couple things. Get rid of this, get rid of this. And yeah, they use the same letters. So what if they told you, it says find the diameter of the circle. Oh, by the way, I almost forgot this. Here's how you label a circle. So you always label a circle by whatever the center of that circle is. So what letter is the center of the circle? That's an O, all right? So I would call it circle, and here's the symbol for circle. You put a circle and then a little dot in the middle. That means what? That means circle, okay? So I'd call it what? Circle O. So that would be circle O. Everybody got it? Okay, so that's pretty important. It says find the diameter of circle O if OD is 3, so from there to there is 3, and AB is 8. And they told you the whole AB. I'll just write it down. AB is 8. And I want to find the diameter of that circle. Yes, sir. What's 4? You just think you know what I asked, but you didn't hear what I asked. Okay? All right? Because I know why you said 4, but that's not the answer. It says find the what? The diameter of the circle. So what is the diameter? It's this whole thing across, right? I know a little bit of it. I know that's 3. I just don't know that little tiny bit right there, do I? But if I did know it, then what would I do to find the whole circle? Find the radius and do what to it? Double it, right. If I find the diameter, look. You're making it harder than it is. Look, if I wanted to find the diameter, if I knew the radius, okay, if I knew the radius, how would I find the diameter? I would just double it. That's right. So I got to find this radius, don't I? All right. Now, this circle, I could draw, I don't just have to go from from O to C to make a radius. I could also go from O to what? D? That would be the radius? That would be the radius? Well, it is A. All right? That would also be a radius, wouldn't it? Okay. They tell you that AB is 8. That's what they tell you. That whole thing is 8. So according to what we just talked about, that theorem, this is a radius, and it's perpendicular to the chord. So what does that mean about AD and BD? They're equal to each other, so D's got to be the midpoint. So if this whole thing is 8, then this has to be what? It's got to be 4. You with me? Now, remembering something that we learned not too long ago. This side is 3. This side is 4. It's a right triangle. So what's the pink one? What's OA? It's 5 because it's a 3, 4, 5 triangle. Pythagorean theorem. Okay? They made this example super easy for you, right? 3, 4, 5. Okay? They could have given you different numbers, but you could have you could have used Pythagorean theorem to find this. So what is OA? It's 5. Well, OA is a what of the circle? No, it's a what of the circle? OA, from the center to a point on the circle. It's the what? It's a, give me a word. It's a radius. It's a radius. Okay? It's a radius. So, what's the diameter then? If the radius is 5, then the diameter has to be 10, and that's how you found the answer. All right? You with me on that? All right, we still didn't quite get to everything. Do as much as you can. Listen, don't talk, listen to me. Do as much as you can on that lesson. And what did I give you? Let me see. Oops, I'm on the wrong class. Hold on. So the lesson, hold up, is 10 to 24. So you may not be able to do the ones towards the end. But my guess is you should be able to do some of the ones at the beginning, okay? So do as many as you can from 10 to 24. Again, you probably won't be able to do the ones towards the end, but at least do a few. I'll finish it up tomorrow, and I'll let you finish that homework tomorrow, okay?